We're looking at differentiation. So this is pure chapter 9 in year 2. And this is section, I believe this is about 9F, okay? So you've seen some rules for differentiation. You've done trigonometry, and we're going to put them together, okay? So this one here, this result, you are expected to know. But you can actually derive this as well, and occasionally this is an exam question. So what do you know about tan? Well, you know that tan is sine over cos, and you've looked at how you differentiate both of those parts there. But you also need to think about the fact that you're differentiating a function over a function. So what rule is that? Well, that's the quotient rule. So let's take a look. If we assign our pieces u and v, and then our du and our dv pieces, well, we can just put them into the pattern. Okay, so v du, that's cos squared, minus u dv, which is a double negative. So it's minus sine squared x. It's all over v squared, which is cos squared. So we end up with this one here when we put everything into our rule. Remember, the advice for the exam technique is you write out what the rule is, and then you substitute the pieces in. That shows that you're trying to do the method, even if you make a mistake. You get 1 on the top. Well, we know that cos in the denominator is the same as sec. So 1 over cos squared is sec squared x. This is a result that you need to know, okay? You need to know that tan becomes sec squared. That's one of the two that you really must commit to memory. We could also do this with a chain rule as well. So, I mean, that's just discussed here. So if you know that tan x goes to sec squared x, it shouldn't be too much of a surprise that tan of 3x, for example, well, you get that part there, but then there's a chain. There's a chain of the 3x. Okay, if you're unsure about that, please check the chain rule in the previous section. So that's one of the really important ones to know. The other one is this one here. So what happens to sec of x? Well, what's the best way to go around this one? Again, using cos, okay? So we know that sec is 1 over cos, and then we can write it like this. In fact, as a general bit of advice, if I'm ever asked to differentiate something with trig and I'm not really sure, so let's say I have something like this, it's much easier if you rewrite it as so. And then you'll be thinking, oh, bracket cubed becomes 3 bracket squared, bracket is sine of x, times whatever this one is. Well, that's cos of x. Okay, it's much easier to differentiate trig by rewriting like this. So that's what they've done here. So in the denominator, you can write it to the -1. And then, well, what does bracket to the -1 become? It becomes minus bracket to the -2. That's what you're seeing here, minus bracket to the -2, multiplied by the part inside. That's using the chain rule. So the chain rule is in effect here, which is minus sine of x. Okay, that can all be expressed like this. If you see a sine and a cos, break them up. Okay, break them up so that you have, so if you have sine and like cos squared, break it up so sine cos appears, because sine over cos anywhere, well, that's your tan part, isn't it? And then 1 over cos is sec. So this is the other really important result to know, which is that differentiating sec x, it becomes sec x tan x. Again, this is just saying here, what would sec of 4x become? Well, the result is sec tan. So sec 4x, tan 4x, but there's a chain rule, so you also have a 4 at the front. That's what this one here is saying. These are the two that you really must know like the back of your hand, okay? If that sounds like an exaggeration and you think, well, do I really? There's no argument. You need to know these like the back of your hand. They will hold you back quite a bit in exam questions for differentiation and integration if you're not able to recognize them and quickly use these results. Okay, so the left-hand side we have just dealt with. Okay, so one of the reasons why I'm saying you really need to know these is because they help you to remember some more difficult ones. Up until now, whenever we've had cot and cosec and sec and things, we've pretty much just been turning them into cos and sine and so on. But that could be very slow. Okay, that could be very, very slow if you have something like cot, because cot, it does actually just have its result, which is here. Okay, so the way I like to remember these is I use this one to help me with this one, and this one to help me with this one. So let me show you what I mean. Tan and cot. Well, that's tan and cotan. So you've added co to the front, so you add co to the result. Yeah? You add co to tan, so cot, where you add co to the result, which is sec squared. So now it's cosec squared. That's part of it. There's one other detail as well, which is when you differentiate by adding co's, so tan becomes cotan, sec becomes cosec, you must have a sign change as well. So this was a positive that has become a negative. Okay, the same applies on the one underneath. So sec becomes sec tan. If you add co's, you must so if you add co's, we got cosec, well, you must add co to the result. So instead of sec x, it's cosec x. Instead of tan x, it's cotan or cot x. And again, look, there's been a sign change. Positive has become the negative. So to memorize this, if you add co's, you do this on both sides. Okay. If you add co's, you also have sign changes. Okay. Positive to negative or negative to positive. And by knowing that, you can answer questions like these ones here. So cosec 2x, we don't need to overcomplicate it too much. It's a bit tricky because there's a quotient rule here. So let's do our u equals v equals. So u equals cosec 2x, v equals x squared. So du equals, well, what did the rule say? Sec becomes sec tan. If you add cos, you add cos. So this is going to be what? This is going to be cosec, which can be written like this, cosec 2x, so sec tan, so cosec 2x, cot 2x. What else? Add the cos, there's a sign change. Anything else? Yes, there's actually a chain rule as well, because it's 2x. So all of du is minus 2 cosec 2x, cot 2x. Yeah? And yes, you'd be expected to do that, okay? This is what it's going to turn into. This is when we start to get quite tricky with the questions. V, at least that one's a nicer one to differentiate. So you put all of that into your rule, simplify where possible. That's how you do part A. Part B, remember the tip I said, when you've got trig to a power, it's a good idea to rewrite it like this. If your chain rule is really good, bracket cubed, you will know that that becomes 3 brackets squared times by whatever's in the bracket. Sec becomes what? Sec becomes sec tan. And it is just sec. So sec x tan x. We could clean this one up here. So sec squared and another sec. So this will all become 3 sec cubed x tan x. An interesting property of sec is that the power for the sec stays the same. So this is sec cubed, and look, sec cubed appears again in it. Okay, except with the tan x. So pause the video and have a go at this one here. Remember to think of this, as you've got over here. So you can do this formally with the chain rule. You will need to use the 3 parts to the chain though, instead of 2 parts. Or if you are familiar with like the layers of an onion, you could sort of use this as a guide. Pause the video, have a go, and I will quickly talk over it. Okay, so let's reveal first of all. How can we quickly differentiate this? Well, the outer level, you can think of this as something squared. Okay, so that has to be differentiated. What's next inside? Well, it's sec of something. That has to be differentiated as well. And then you also have 3x. All of these parts need to be differentiated and multiplied together. So this will become 2 bracket 1, won't it? And the bracket is sec 3x. So that's where this pi here is coming from. What's sec of bracket going to become? Well, that's going to become whatever sec bracket, I mean, it's 3x here, tan. That's the rule that we just looked at. So that's where this part comes from. Okay, And then this is times 3, which is where that part comes from. So if you want to know how to quickly do this, it takes quite a bit of practice to get really comfortable with the chain rule like that. That's the quick way to do it. We can simplify to get to this one here, but we ask ourselves that question. This is what I have. This is what they have. Tan 3x, that looks pretty, no, tan 3x there looks pretty good, but you've got sec squared. You have sec squared. They have tan cubed. Well, it's not quite the same thing, but there is a way to get from sec squared to tan squared, isn't there? And that is using the identity, okay? So sine squared plus cos squared equals 1. How can I get sec and cos? I can divide by cos. So tan squared plus 1 must equal sec squared. So what they've done is this one here has been replaced with this one here, okay, using this identity. So tan squared of 3x, remember it's an identity, so it works for any input. So here my input is 3x, is equal to sec squared 3x. Okay, that's what's happened. Another property we should talk about is sometimes you will kind of have an upside down question. So what do I mean? So I mean this one here. Now, if I asked you to differentiate that, hopefully you would give me quite a quick answer now. You would say to me dy dx equals sec squared. Well, this is exactly the same thing, but with the x's and the y's in the same position. So I could say dx dy. I could differentiate with respect to y's instead, because look, this bit here has a y. That's the bit you want to differentiate. So I could get that result there. But the question says dy dx. It also says in terms of x. So there's two issues with what we've done there. The first thing we can do to fix it is we can sort of do the reciprocal on both sides. Or if you prefer, this is sort of the same as turning things upside down. So there's a little bit of space over here. Let's use this space. So dx dy equals sec squared y. Easier if you do it like that. Turn it upside down. Dy dx equals 1 over sec squared y. And now you've done that one there. Well, the final part is you have to think, how can I stop talking about y and start talking about x? So you need to think about what links x and y together, what might help you with that. So let's take a look at a neater version. So we've achieved this one here. Now, the only thing really in the question that connects x and y together is this original statement here, okay? You've got something about sec squared, but there's something here about tan and x. So this is your only way in really to talking about x. Now, we know this identity here. We just saw that, I think, on the previous slide. So 1 plus tan squared y equals sec squared y. Well, you could remove the sec squared and then you would have that. Again, though, that's not helpful because it says in terms of x. However, you know that x is tan y, so x squared must be tan squared y. So that's sort of your final way to change those parts there, okay? And sort of make sure you answer the question, because it did say in terms of x. So two things going on really. One of them is sort of like the upside down trick, if you like, dx dy to dy dx. But then you need to sort of problem solve a little bit, which is how can you move away from talking about something in y to x, and you need to use what's available to you, which tends to be the question itself. Just one note here. Indirectly, what you have done is you found the derivative of arctan here. So this is a bit confusing depending on how old your book is. You may see questions like this. They are not in your specification anymore, okay? So if you're looking at any old slides or things like this, you can ignore this section here. This is from the exam board themselves. I think it's on page 248. So just a quick note, although we do this dx dy upside down and substituting as you saw on the previous slide, this would be the limit, okay? That is the limit there in terms of that skill and how far they will expect you to do that on the regular A-level course. So please watch out for page 248 in some of the textbooks. I think in the newer textbooks, this has been removed. Okay, have a quick go then at that question there on the board. So pause the video and have a go based on what we just said. Okay, so for part B, hopefully you've realized part B is the starting part of what we just did. So we differentiate, we get dx dy equals, well, we know this one now, so we know this will be sec 2y tan 2y. Chain rule as well, there'll be a 2 there. So that's all they want for this 2 marks. Find dy dx in terms of x. That was the tricky bit that we just looked at. So you have to, well, we do have to turn it upside down. So dy dx equals 1 over all of this stuff here. But now you've got to stop talking about sec 2y tan 2y. You need to find a way to talk about x. Some of you may notice that sec 2y can be removed straight away. This whole part here can be changed to just an x. The tan 2y, though, is more difficult. So what links sec and tan together? It's that identity again, isn't it? So the answer is going to feature something about x squared. So we talked about this line here. You change the sec 2y to an x. How do you change tan 2y? So we use this identity here. Okay, and you should find that tan 2y equals x squared minus 1. Now, the only issue with that is you don't have tan squared, you have tan. So you end up with this root here. Okay, so 2x and then this root. And that might sound to you like a really sort of horrible answer, but you have answered the question. That is dy dx, and it is in terms of x. Okay, the right-hand side there is left as a challenge question. So before you go off answering the questions, please make sure that these results, so especially the ones on the left-hand side, and quickly using those to get the right-hand side, the left-hand side at least needs to be like the back of your hand. If you need to spend 10 minutes doing that for the next week, then you need to spend 10 minutes doing that. Okay. No talk about formula booklets or anything like that is going to change it, because we're going to get to integration later. And again, you need to recognize and quickly use these results. You will not want to spend your time deriving them unless the exam wants you to do that specifically. Okay, so that takes you up to 9F.